this video, we are going to see the different layers that is involved in PCB design. So there are three classifications of a PCB. First one is a single layer PCB, second is a double layer PCB, or a third can be a multi-layer PCB, which means whenever you are designing a PCB, it can be designed in such a way that it might be either a single layer, double layer, or a multi-layer. So we are going to see what is single layer PCB. In general, in lower classes, we all might have used a breadboard design. If I consider the case of a breadboard design, how the breadboard is going to be is the components will be placed at the top of the breadboard and none of the components will be placed at the bottom of a breadboard. This is an example of a single layer PCB, which means you can place the components only at the top portion. None of the components will be connected to the bottom portion. So if we look into the schematic of a single layer PCB, there is a substrate material that is being connected at the bottom of any kind of PCB. You have to know what is this the substrate material is. See, whenever we are constructing a building, the basic part that is involved when we are constructing a building is a basement layer. We will be having a basement layer. Over the basement layer, we will be constructing the ground floor and then a first floor and then a second floor, and it goes on. Similarly, whenever we are constructing a PCB layer, make a remember that the background portion or the bottom portion that is being highly involved is a substrate layer. This substrate layer is going to act as a base layer that is similar to a building, that is a basement. Over this layer, we are going to place an interconnecting layer or a copper layer that is used. So this copper layer mainly concentrates on providing an interconnecting layer. And over this copper layer, there is one more layer that is connected to it, named as a solder mask. You have to know what do you mean by the term mask. I hope you all know what is the concept of soldering. We are going to place a component and we are going to fix the component by the means of soldering material. In general, whenever we consider a dotted board that is being available, what we used to do is we used to select which place to fit a component, and then we will be place a component over it, and at the bottom side of this particular board we will be using some soldering component to establish a connection in this dotted board. A similar case is a solder mask, but this mask will be done automatically, that is mechanically. This is not going to be done manually. And you have to know what do you mean by the term mask. See, in this PCB layer, whenever we are constructing a PCB layer, the main objective that is needed when we are constructing a component of a PCB layer is, one is a base. Base represents an insulating material, which means whenever we are constructing a PCB layer, if suppose I am placing a component like this, and if the second component is being placed like this, in between the two components we need to provide some isolation to prevent the interference problem. That is the main objective why we are using some spacing between placing of one component and the another component. So whenever we are placing a component, we need to decide where the components are need to be placed. This is done with the help of mask. Mask in the sense, I need to place a component at this place, I need to provide an interconnection in this place, so I need a mask layer. The remaining portions can be isolated, which means only the portions that are covered with the mask will be used for placing the component. The remaining portions will be left unconnected. This is the meaning of masking of a layer. And the second case is double layer. If the same circuit is being available at the top layer and the bottom layer, then this is named as a double layer. In the case of a top layer, the same component, that is a substrate element, a copper layer and the solder mask will be present in the circuit. Similarly, in the bottom layer, the same copper substrate and the solder mask will be present in the circuit. So if instead of having a single layer, if it is being available at the top and the bottom portions, then such a kind of a PCB is named as a double layer PCB. If it is a multi-layer PCB, we will be having a number of layers of PCB that are being connected together. It is similar to a sandwich structure that we can see it. That is, I will be having a PCB layer and then I will be making one more PCB layer that is placed over it, and then one more PCB layer, and it goes on. This is an example of 4-layer PCB where nearly 3 PCBs are placed at this layer and there will be 4 different copper materials that is placed over it. So hence it is named as a 4-layer PCB. It is not a restriction that only a 4-layer PCB should be made. Advanced techniques concentrates even a greater layer, that is of 4. That is, they are constructing a 6-layer PCB, 8-layer PCB, 14-layer PCB, and this goes on. So this is done with the help of multi-layer PCB. So the classifications of PCB are a single layer, a double layer, and a multi-layer. Based on these classifications, a number of PCBs are also designed in nowadays. If I consider to the circuit that is available in my lab, it can be visualized that you could see a number of PCBs that is being connected in this. To start with, first we name it as a double layer PCB. Second one is a multi-sided PCB. Multi-sided in the sense we are going to connect it on either of the side, that is a top layer and a bottom layer. Not only top layer, bottom layer, I can also connect it in the left and the right hand portions. And the third one, that is named as a rigid flux PCB. This is named as a rigid flux, meaning is some portions cannot be altered, but some portions can also be bended like this. This is named as a rigid flux PCB. This type of PCB supports for high frequency applications. So say for example, whenever I am going to design named as a radio, if I am going for this, then I can go for a high frequency PCB, and this is single sided PCB that is being already discussed, and this layer is named as an Aluminium Pack Pcb. See, we know that there is a substrate material. In this case, the substrate material is being taken as an aluminium, and I told one more term that is named as masking. You could see a brown portions that is being indicated at the top of the layer, and there are 2 different components that is placed over it. How I am saying it is the 2 different components is because there is an insulating layer that is being provided in between these 2. So this is how masking is being performed. The layer there a component needs to be placed should be a masked one. Which means there should be some component that is placed over it. So this is an example of an Aluminium Pack PCB. Not only like this flexible type PCB are also being available in this market, where you can bend this PCB to any ratios. But even though if you are bending this PCB, its functionality is not going to be altered at all. So this is an example of a flexible type PCB. And the last one is rigid PCB. This PCB you might have seen in an Arduino board. If I am taking the case of an Arduino board, the board cannot be bent like similar to this flexible PCB. It will be made standstill. Say for example, the motherboard that I was showing in the previous video is an example of a rigid PCB. So this cannot be made bent at all. So based on the layers of a PCB, we can further extend the classification of a PCB like this, named as a double layer PCB, multi-sided PCB, rigid flux PCB, high frequency PCB, aluminum pack PCB, flexible PCB. So these are some of the advancement technique that is being available in the recent market. In the next slide, we are going to see how this PCB is being made up of and what are the contents that is going to be dealt in this particular one credit course.